Hello, welcome to a video discussing factoring solving by factoring for sections 4.3 and 4.4. So here we're going to be on pages 9 and 10 of the Chapter 4 notes. It does say Chapter 4 Lesson 4 on the top left corner, if that helps. So again, we're going to discuss factoring, stuff that you guys did in middle school often. A lot of it should be review. The one thing we're going to start with is something called GCF, which stands for the greatest, apart from messy handwriting, greatest common factor. So we'll start by doing that for number 1. So you want to do is you want to look at all the terms involved and see what they all have in common, and then pull out the greatest of all the common factors. That's why we call it the GCF. So hopefully you could see that for part A, 5 is common between 5 and 45, so we pull it out. And it's really like division, right? Because 5 divided by 5 is 1, so you get x squared. 45 divided by 5 is 9, so we get negative 9. And that's factored. Let me change colors for a bit of contrast. So what's the GCF here? They all have a 3 as a common factor because they're all divisible by 3. 3, 15, 42 are all divisible by 3. And they all have an x in common. So we're going to pull out a 3x. So you get x squared plus 5x minus 14, I believe. Now, you could factor this further if you have a trinomial. So this right here, we call it a trinomial for obvious reasons. It's a polynomial of 3 terms. And sometimes you could do a little trial and error. So what you do is you try to find 2 factors of negative 14. You might remember this process, perhaps you did in middle school. If not, I can talk to you guys about it in class again. But what you do is you put the constant over here and the linear term over here, and you find 2 numbers that multiply negative 14. And add to 5. So a little trial and error, but if you go through all the possibilities, there's like 14 negative 1, but 7 negative 2 work. And when if you were to FOIL, meaning you do first, outside, inside, last, it would get you back to the trinomial. So this is actually the final answer. So we did the GCF, we also had to do a bit more. And we'll talk about that in the other examples. This one's pretty easy. The GCF is 2y. So you factor out 2y, you get x squared plus 4. Now that's not factorable, mind you. There's no way I could break that apart and get something that would multiply x squared plus 4, so we just leave it like that. Now if it's x squared minus 4, that would be x minus 2 times x plus 2, just so you know. And actually, it just kind of dawned upon me. I do have a factoring flow chart here that might help. Yep, there we go. I'll post this to Schoology, but something you can kind of think about, and I'll kind of come back to that when we approach some other polynomials of factor. So in this case, we have 3 terms. So are there any common factors? Nope. They don't all have x in common. There's no other numbers in common. Are the first and last terms perfect squares? Actually, they are. And so if the answer is yes, you factor it like that. So it's going to be x, negative 9, negative 9, or you could write like x minus 9 squared. That will work as long as when you FOIL, that the middle term becomes negative 18x. You could do that to make sure you check that does happen. Well, in this case, we square root both sides. X minus 9 equals 0. X equals 0. That's pretty easy. So that's what the advantage of factoring is, that you can solve quadratic equations quite easily if you're comfortable factoring. And I'll get you comfortable, but we'll just have to practice it in class. Now here, you're going to have to put all terms on one side. So very important. Collect all terms on one side. Why is because when we factor, and we're going to do this little diamond thing that I talked about earlier, you find 2 numbers that multiply negative 63 and add up to 2. So there we go, 9 and negative 7. And if you're ever stuck, you can always just kind of list all the factors until you hit it. And I think we would eventually hit it over here, or some variation of that. So great. So x equals -9 or 7. So what we're doing here, the reason why we had to collect all terms on one side, we're doing something called the zero product property, which I'm going to ask a question about that on the Google form. The zero product property, as it implies, is that any number times 0 equals 0, right? Any number times 0 equals 0. So if x is -9, guess what? That's going to become 0. Who cares what's over here? 0 times anything is 0. That's why you got to collect all terms on one side. You got 0 on the other side, and you got all the other junk on the left side or right side, wherever it is. And then you try to figure out what would x have to equal so that your product is 0. So it's very important that you do isolate or get all terms on one side and make sure 0 is on the other side of the equation. Very important. Let's look at 3. This is involving FOIL. So first, outside, inside, last. So it's the reverse of factoring. I know sometimes when people factor, they call it foiling. You want to make sure you're precise with your language. FOIL is the reverse of factoring. I may ask that as well in the Google form. So you get 3x squared minus 21x plus x minus 7, 3x squared negative 20x minus 7. There you go. And if you're a factor it, you would get back to that. In fact, if I were to factor it, I would do this. Now in this case, I'm doing a times c, not just the constant, but that's a, and that's c, and that's going to be b. Put b right there. So you find two numbers that multiply to -21 and add to -20. Well, guess what? That's going to be -20 and 1. Nope, sorry, I lied. That multiplied to -21. Oh, -21 and 1. There you go. And of course, that adds up to -20. But if you were to factor it, what's going to happen is that it would look like this. 3x squared minus 21x plus x minus 7. You do factor by grouping. I pull out a 3x. And it's not I can pull off from this one, so I'll just put a 1 right there. So guess what? X minus 7 being multiplied by 3x plus 1. So it gets me back to what I had originally. So here's the process of factoring something when a is not. The factor process when a does not equal 1. It's pretty easy when it does equal 1, like in the case of number 2 part B, or number 2 part A, I guess. But a little tougher here, so let's try this again. I'm going to put 30 and -17. Remember A, B, C. AC is right there, B is there. Two numbers that multiply to 30 and add to -17. Actually, -2, -15. There you go. 5x squared minus 2x minus 15x plus 6. So we're going to factor by grouping. So what's going to happen is I'm going to pull out a x to get 5x minus 2. I'm going to pull out a -3 to get the same thing. All right, 5x minus 2, x minus 3. And if you're to FOIL, it will get you back to this. That's how you can check your work. Okay, let's try a few more. I'm not sure it's called the AC method. I'll ask Ms. Wong about that. But let's try this again. Let's go through our flowchart. Are there any common factors? Nope. The first last one's perfect scores. Actually, they are. So we kind of lucked out. 3y, 3y, 2 and 2. And if you were to FOIL it, it would get you 12y in the middle. You get 6y plus 6y. So we got kind of lucky there. Or you could write it like this. If you so desired, we could have done that technique. You get 6 and 6. And then you can factor out 3y. Yeah, so anyway, let's try it again. Negative 80 and 38. Now, negative 8 is kind of tricky. There's a lot of different options like negative 1 and 80. It's a little bit of a trial and error, but you could be systematic still. Oh, I hit it. Negative 2 and 40. So you got 8c squared minus 2c plus 40c minus 10. And what we're doing, actually I should have been a little more clear about this, and I'll probably put this in the Google form as well, is we're splitting the middle term. That's actually what we're doing with this cross or this x method, is that we're taking 38c and splitting it into negative 2c plus 40c by using this process up here. And actually maybe that's what Ms. Wong meant by the AC method, is that you're doing a times c. So I'm pretty sure we're on the same page there. Now we do factor by grouping. Factor out 2c, you get 4c minus 1. You can factor out a 4 from this one. No, 10. 4c minus 1. And so you get 2c plus 10. And you know, I forgot to pull out a GCF. Oof, shame on me. Take this 2 out. You got that. And you just factor, not solving, so you don't have to go any further. It's just factoring is fine. Okay, we got one word problem. You got a rectangular picnic site, 24 by 10. You want to double the site's area by adding the same distance x to both the length and the width. Okay, fair enough. Now write an equation to represent the new picnic area. So originally, there is 240. The new area is going to be 40 because we told you want to double the area. And remember, area of a rectangle is length times width. So the area is now double, and the new length is 24 plus x. The new width is 10 plus x. Go about this by solving. So I'm going to FOIL the right side. Move everything over to one side. Kind of rearrange things so we're going in descending order of the exponents. And oh, I made a mistake. That should be 24x. I knew something seemed a little fishy there. I was like, I'm not going to be able to factor this. Okay. I have to be a little bit clever here. 40 and negative 6 are my factors, and that's not x squared. Sorry about that. So x plus 40 minus 6, x is negative 40 or 6. We're not going to use negative 40 because you can't have a negative dimension, so I might ask that also in the Google form. But x is 6, so that's what you're going to have to do. Add 6 feet. To each side. And that concludes the video. Okay, we'll see you guys later. Goodbye.